In this lesson, we're going to talk about oxidation numbers. First, what are oxidation numbers? This is the number of charges an atom would have in a molecule if the electrons were transferred completely. In ionic compounds, we see a transfer of electrons, but in covalent or molecular compounds, we see that electrons are being shared. However, we pretend in those molecular compounds that they're transferred completely because that's a bookkeeping method that helps us better understand and explain what's going on in a chemical reaction. We have a set of rules to help us identify the oxidation numbers of every element in a species. And we're going to follow these rules, and it's important that we go in order when we start looking at assigning oxidation numbers. The first rule is that free elements have an oxidation number of 0. Note that there are no charges on these. So we have Li for lithium, Ni. We can also have molecular elements such as O2 or Cl2. All of these have an oxidation number of 0. Our next rule concerns monatomic ions, and in this case, the oxidation number is equal to the ionic charge. For Li plus, F minus, Ti4 plus, we'll have oxidation numbers of +1, -1, and +4. Note that these ions may be in a compound, so we may not see the charge, but we know from what we learned about ionic compounds that we can figure out what the charge is on those atoms. Third rule is oxygen has an oxidation number of -2. In the vast majority of cases, we see that it can have a -1 oxidation number, but only in H2O2 in the peroxide ion. Rule 4 is for hydrogen. The vast majority of time, hydrogen has a +1 oxidation number. The only exception is when we have it in a binary metal compound. So we see a metal, such as lithium or calcium, as the examples show here, paired with hydrogen. And in that case, it's going to be a -1. However, we do not see these compounds very often. So the vast majority of times, hydrogen is +1. Rule number 5 is fluorine has an oxidation number of -1. No matter what it's paired with, no matter what the compound is, fluorine will always be -1. And the last rule we'll see is that other halides, so chlorine, bromine, and iodine, are -1 when they're in a binary ionic compound, but in some compounds, they can actually have a positive value. Which two are free elements? N3- is a monatomic ion. Cl2 is a free element. Helium is a free element. And H2O is a compound. Therefore, B and C are the correct answers. And both of these will have an oxidation number of 0. Looking back at rule number 2, the oxidation number of a monatomic ion equals its charge. Sometimes the charge is explicitly shown. For Na+, it has an oxidation number of +1. Mg2+ has an oxidation number of +2. S2- has -2. And fluorine- has -1. However, because we have an ionic compound, we also have ions in that ionic compound. And we can still determine the oxidation number based on the charge of those ions. Remember, an ionic compound is a metal and a nonmetal, or we can have a polyatomic ion substituting for one or both of those elements. When I look at NaCl, I know that Na has a +1 charge in an ionic compound because it's in the first column of the periodic table, so its oxidation number is also +1. Chlorine has a charge of -1, therefore its oxidation number will also be equal to -1. Magnesium is in the second column of the periodic table, has a charge of +2 in an ionic compound, so its oxidation number is +2, and the oxidation number of chlorine is still -1. Note that we look at the oxidation number per atom. Even though there are 2 chlorines, we talk about the oxidation number of each chlorine atom. The sum of the oxidation numbers in a neutral compound equals 0. Looking at our example with NaCl, we have a +1 and a -1 oxidation numbers. We see that +1 -1 equals 0. For H2O, we have +1 and -2 for hydrogen and oxygen. We know that we have 2 times plus 1 plus minus 2 equals 0. Knowing the oxidation number of some of the elements will allow us to find the oxidation number of other elements in the compound that are not determined by the rules. Another guideline we can use is the sum of oxidation numbers in polyatomic ion equals its charge. Similar to our sum of oxidation numbers in a compound equaling 0, in this case, they're going to equal the charge on that polyatomic ion. For example, NO3 minus or nitrate, we don't have a rule that applies to nitrogen, so we're going to label that X. We know that each oxygen has an oxidation number of -2, and because that ion has a -1 charge, we know it's going to sum to -1. X plus 3 times -2 equals -1. X minus 6 equals -1. I add 6 to both sides and get X equals +5. So I've identified the oxidation number of nitrogen based on this rule. Our next example is with the dichromate ion. We don't have a rule for chromium, so we label that with X. It's our unknown. Again, oxygen has a -2 oxidation number, and that's per each oxygen. And we know the sum of those will be equal to -2. I do have to take into account that we have 2 chromiums and 7 oxygens. So 2 times X plus 7 times -2 equals -2. 2x minus 14 equals -2. I add 14 to both sides and get 2x equals 12, and then divide both sides by 2 to get x equals +6, which is my oxidation number for each chromium in the dichromate ion. Assign oxidation numbers to each element. Looking at these examples, we have no free elements, so we're never going to worry about that. Next, we look for monatomic ions, NHClO3, and I don't see any there. I have rules for oxygen and hydrogen. Hydrogen has a +1 oxidation number, oxygen has a -2, and I'm going to label the chlorine as X because remember, chlorine can have a -1 but can also have some positive values. I know that the sum of the oxidation numbers of these elements must equal 0. So I take +1 plus X plus 3 times -2 and sum those to 0. Get 1 plus X minus 6 equals 0. X minus 5 equals 0, and X equals +5. So I've identified the oxidation number of chlorine as +5. For Cl2O7, again, chlorine is my unknown because halogens can have different oxidation numbers. Oxygen is -2. I can take 2 times X plus 7 times -2 and add that up to get 0. 2x minus 14 equals 0. 2x equals 14, and x equals +7. So the oxidation number of chlorine is +7, and oxygen is -2. Cl2O, again, chlorine is labeled as X. Oxygen is -2. We have 2x minus 2 equals 0. 2x equals 2, and x equals +1. We have 3 examples here, all including chlorine. All see a different oxidation number for chlorine in that compound. What is the oxidation number of nitrogen in NH3? We don't have a rule for nitrogen, so we're going to label that X. Hydrogen has an oxidation number of +1. X plus 3 times +1 equals 0. X plus 3 equals 0, and X equals -3. What is the oxidation number of nitrogen in calcium nitrate? For calcium nitrate, we have an ionic compound. Therefore, we can identify the oxidation number of calcium as +2 because that's the charge that it takes on in an ionic compound. Nitrogen is our unknown. We label that X. Oxygen has an oxidation number of -2. Now we can sum the oxidation numbers to 0 and identify the oxidation number of nitrogen. We have 1 calcium, so +2. 2 nitrogen, so 2 times X. 6 oxygen, so 6 times -2 equals 0. We get 2 plus 2x minus 12 equals 0. 2x minus 10 equals 0. 2x equals 10, and x equals +5. So the oxidation number of nitrogen is +5. What is the oxidation number of carbon in CH4? For CH4, we don't have a rule that applies to carbon, so we label it X. Each hydrogen is +1. We know the sum of the oxidation numbers equals 0. X plus 4 times 1 equals 0. And then X equals -4. What is the oxidation number of carbon in C2H6? Again, no rule for carbon. We label it as X. Each hydrogen has a +1. 2x, because there are 2 carbons, plus 6 times +1 equals 0. 2x plus 6. 2x equals -6. Therefore, x equals -3. The oxidation number of carbon is -3.